Have you ever flown across the world and wondered, wait, how is it still the same day? Or questioned why your phone suddenly jumps an hour ahead in March? Timekeeping isn't just about clocks, it's about geography, astronomy, and even politics. Let's dive into the real story of how we tell time across the planet. Hi everyone, and welcome back to the channel. If you love exploring how the world works, from geography to global systems, don't forget to hit that like button and subscribe. It really helps us grow and bring you more content like this every week. Now let's unravel the science and history behind telling time. Before we jump into time zones, let's understand what time really is. As Canadian physicist Malcolm Thomson once said, there are only three natural units of time: the day, the month, and the year. These are based on the Earth's rotation, the Moon's orbit, and our trip around the Sun. Everything else, from seconds to hours to decades, is a human invention. Early humans used the sun's position to track time. Sunrise meant the start of the day, and sunset meant time to rest. But as civilizations advanced, we needed something more precise. In places like Egypt, Mesopotamia, India, and China, ancient astronomers observed sun and the stars to mark calendars. Local solar noon can be determined by watching for the moment when objects cast their shortest shadows. The Romans used sundials, measuring time by the shadow cast at noon, what they called the meridian, the sun's highest, merry, point of the day, diem. That's where we get AM for ante-meridian and PM for post-meridian. Pretty cool, right? But here's the catch: every town had its own noon, based on when the sun was directly overhead. So 12 o'clock in one village could be 12:20 in the next. That worked fine, until we started moving faster. As trains and telegraphs connected distant cities in the 1800s, this patchwork of local times created chaos. Imagine catching a train from New York to San Francisco and having to reset your watch 24 times. Yeah, not fun. So in 1884, the world came together at the International Prime Meridian Conference in Washington, D.C. The solution? Divide the Earth into 24 standard time zones, each 15 degrees of longitude apart. The starting point was Greenwich, England, known as the Prime Meridian. The world's time zone system is built around one starting point, the Prime Meridian, which runs through Greenwich, England. This line is set as 0 degrees longitude, and its local solar time, meaning when the sun is at its highest point there, is used as the global reference. This became known as Greenwich Mean Time, or GMT, now called UTC or Coordinated Universal Time. Now, since Earth rotates 360 degrees in 24 hours, each 15 degrees of longitude equals 1 hour of time. So, the planet is divided into 24 time zones, each roughly 15 degrees wide. The prime meridian is at the center of its own time zone, which stretches 7.5 degrees to the west and 7.5 degrees to the east. The same logic applies east and west across the globe. Every 15 degrees from Greenwich marks the center of another time zone. So, if you're 15 degrees east of Greenwich, your local time is 1 hour ahead of UTC. If you're 30 degrees west, your time is 2 hours behind UTC. That's how the global time zone system is organized. In theory, it seems simpler. But in reality, countries adjust these boundaries for practical reasons, like politics, economics, and convenience. For instance, Europe from Portugal to Poland shares one time zone, even though it spans about 30 degrees of longitude. And China, despite stretching across 4 natural time zones, officially follows just one, based on Beijing time. Larger countries often use multiple time zones. Russia uses 9. The US, including Alaska and Hawaii, spans 6. Canada has 6, and Australia uses 3. In contrast, smaller countries usually fit neatly within a single time zone. Some countries also follow time zones that aren't whole hours offset from UTC. India, for instance, uses UTC plus 530, based on the 82.5 degrees east meridian. If each town followed its own local solar time, it would be chaotic. Even towns just a few degrees apart would show different times. That's why standard time is so important. It keeps things coordinated, especially for travel, communication, and trade. As you travel around the Earth, something fascinating happens with time. It shifts with your direction. If you travel eastward from Greenwich, you gain time until you're 12 hours ahead at 180 degrees east. Going westward, you lose time, 12 hours behind at 180 degrees west. That's a total difference of 24 hours or one full day between these two sides of the globe. To manage this, a line was established where the calendar date changes, called the International Date Line. It mostly follows the 180 degrees meridian, cutting through the open Pacific Ocean to avoid populated land areas. But in some places, the line zigzags. For instance, it shifts eastward to keep Kiribati's islands on the same day and bends around the Aleutian Islands of Alaska for consistency. Here's how it works. When you cross the date line from east to west, and you jump forward one day, and when cross it from west to east, and you go back one day. This concept became clear during the first circumnavigation of the globe. In 1522, after Magellan's crew returned to Spain, they discovered their calendar was off by one day, even though they had carefully logged each day. They hadn't accounted for what we now call the International Date Line. It's important to note that when you cross the date line, the time of day stays the same, only the date changes. This clever global adjustment ensures that even as time shifts with our movement, our calendars stay coordinated around the world. Now, let's talk about daylight saving time. This idea started during World War I when Germany pushed clocks forward by an hour to conserve energy. More daylight in the evening meant less electricity for lights. And today, it's still followed in countries like the US, Canada, and much of Europe. For instance, in March 2025, most of the US moved clocks forward an hour, losing sleep, but gaining more light in the evenings. In spring, we spring forward an hour, and in fall, we fall back. And in tropical countries, where daylight barely changes year-round, daylight saving doesn't make much sense at all. Russia once even adopted double daylight saving time, 2 hours ahead of sun time. Still, the practice is debated. Some argue it causes sleep disruption, offers little real energy savings, and complicates global scheduling. Despite the debate, many countries continue using daylight saving time, at least for now. So why does all this matter? Well, telling time isn't just about when to wake up. It's a global system that keeps planes on schedule, financial markets in sync, and your phone alarms ringing at the right hour. It's a mix of science, history, geography, and practicality. And as our world becomes more connected, understanding time, how it's set, how it changes, and why is more important than ever. Thanks for watching. If you found this fascinating, give the video a like and subscribe for more deep dives into the science and systems that shape our world. Got questions about time zones, travel, or weird calendar quirks? Drop them in the comments below. We love hearing from you. Until next time, stay curious.